Hello, and welcome to Remcom's booth at IMS 2019. I'm Jeff Barney. I'm a product marketing manager at Remcom, and we develop electromagnetic simulation software. We've been here talking to engineers about antenna array analysis and a new metric that we're using, and this has been coming up recently just due to 5G technology and the increase in phased array design. So I have an example here of a smartphone. There is two phased array antennas on this phone. There's one on the left side and one on the right side. And if we feed each antenna element with a 0-degree phase shift, we'll get a directional pattern like the one we're seeing here. We can also vary the phase shifts in order to steer the beam up and down the phone, and the images on the left show 3 different beam states. The large image on the right shows 6 beams overlapped on each other. And the trick here is to find a single metric that can be used to quantify the performance of this array. In traditional SISO antenna applications, engineers would look at half-power beam widths or total radiated power. And those metrics, however, get unwieldy when you try to analyze multiple beam states. So instead, we have developed a single metric that characterizes the antenna performance while considering all beams at once. So this is a graph showing the cumulative distribution function of EIRP over the full 3D far zone sphere. Across the bottom of the graph is EIRP, ranging from 5.2 to 37.5 dB milliwatts, and the y-axis is the probability from 0 to 1. For 23 dB milliwatts of input power, we can see that the antenna array provides an increased gain over 75% of the angles on the far zone sphere. For comparison, let's look at a second case where the phone can dynamically switch between an array on the left and on the right side. This is similar to a spatial diversity application. When we look at this graph, we can see the 2 arrays are able to provide much better performance, and now the lower end of EIRP is 27.5 dB milliwatts. So I've covered this fairly quickly, but if you have any questions, certainly look us up at remcom.com, or if you're at the show, please stop by our booth and we can discuss. In this example, I just showed you a spatial diversity application, but this also works for dual polarized antennas or 2D MIMO systems where there may be subsystem arrays that you want to analyze. So again, thank you for your time, and hopefully we can talk more about this if you stop by. Thank you.